Here we have a SAT math question. Okay, let's go with the information. A marble is thrown upward from a ground height of 11 inches. The marble reaches its maximum height of 19 inches in 4 seconds. The trajectory of this projectile motion is in the shape of a parabola. If the height of the marble after it was thrown is represented by the function h of t equals to a times t square, positive b times t, positive c, where t is time in seconds, what is the value of b positive c? Okay, here a marble is turned upward from a ground height of 11 inches. Okay, let me draw a graph for this one. For that, first let me draw a horizontal axis and vertical axis over here. And let me finish sketching the graph. Okay, I'm taking the height reached by the marble h of t on vertical axis and the time t in seconds on horizontal axis. So here this is origin, and also I'm saying this is a ground level. So actually the marble is thrown, let me go over the information. A marble is thrown upward from a ground height of 11 inches. So now let me mark the number 11 over here. So this is a ground height of 11 inches. So please remember, the marble is not thrown from the origin. It has been thrown from a ground height of 11 inches. This is a point at where the marble is thrown. So at this point, the t is 0 because that's the initial time. So since we have taken t, time on horizontal axis, always I have to write the t value first. I mean the value of the variable on horizontal axis at first, and the value of the variable on vertical axis next. So here h of t is 11. So this is 0, 11 is a point at where the marble is thrown. And so the question clearly says the trajectory of this projectile motion is in the shape of a parabola. That is, the path of the marble is a parabola. So it's going like this. It has reached a maximum height somewhere else, and it comes back to the ground like this. Okay, usually whenever the parabola opens down, so we have the maximum point at the vertex of the parabola. So here the parabola, I mean the path of the marble or the trajectory of the projectile motion is an open downward parabola. So we have the maximum point at the vertex. That's the maximum height reached by the marble. So it is given in the information that is the maximum height reached by the marble is 19 inches in 4 seconds. So as I said already, always we have to write the value of the variable that we have on the horizontal axis. So here we have t. So we have to write time first, that is 4, and the maximum height is 19 inches. So this is the value we have for the variable on vertical axis. Okay, now here we have the parabola which opens down, and also we have the vertex of the parabola. Okay, since we know the vertex of the parabola, first what we can do is we can write the quadratic function in vertex form. So which is h of t equals to a times t negative h the whole square positive k. So here h comma k represents the vertex of the parabola. So here the vertex is 4 comma 19. So that is, we can plug in now 4 for h, h over here, and 19 for k over here. Then I'm getting h of t equals to a times t negative 4 the whole square positive 19. Okay, now what we have to do is we have to get the value of this unknown constant a. So for that we can use one of the points on the parabola. So we know that 0, 11 the point on the parabola. So we can use this point to get the value of this unknown constant a. So for that we have to plug in the first value, that's the value of t. This 0 for t over here, and this 11 for h of t over here. So when I do so, I'm getting 11 equals to a times 0 negative 4 the whole square positive 19. So 11 equals to a times negative 4 the whole square positive 19. So 11 equals to, so when I evaluate this negative for the whole square, it's a positive 16. 16 times a is 16a positive 19. Okay, now let's find the value of a. In this case, for that I have to subtract 19 from both sides. So when I subtract 19 from both sides, it's positive 19, negative 19 will cancel. So when I simplify this 11 negative 19, I'm getting a negative 8 equals to 16a. Okay, let me write the stuff over here and continue. Negative 8 equals to 16a. Let me divide both sides by 16 to solve for a. So the 16 will cancel. 8 goes into 8 one times, 8 goes into 16 two times. I'm getting negative 1 half for a. Okay, now what I'm going to do is I'm going to plug in this value negative 1 half for a in this quadratic function. So let me do it. So here we get h of t equals to negative 1 half times t negative 4 the whole square positive 19. Okay, here we have the quadratic function in vertex form, but we have to get the quadratic function in this general form, so that we'll be able to get the values of a, b, and c. Once we get the values of a, b, and c, we can add the values of b and c to get the value of the expression b positive c. So for that, what we have to do? So negative 1 of, I have to expand the square of the binomial over here. So for that, what I'm going to do is I'm going to consider the algebraic identity, that is a positive the whole square, which is equal to, sorry, not a positive the whole square. I have to consider the algebraic identity a negative the whole square. So because here we have negative sign between t and 4, so the expansion of the square of the binomial over here is a square negative 2ab positive b square. Okay, so now to get the expansion of this one, we can use the identity that I have written over here. So for that, what I'm going to do is, like, instead of a, we have t. So at the place of a square, we have to write t square negative 2 times a times b. So 2 times a is t and b is 4. 2 times t is 2t. 2t times 4 is 8t. Positive b square. For b, we have 4. B square means it's 4 square. So our 4 square, we can write 16 over here. So positive 19. So h of t equals to, now we can distribute this negative 1 of to this t square negative 8t and positive 16. When I distribute this negative 1 of to this t square, I'm getting negative 1 of times t square. So negative times negative will become positive. 1 of times 8t will become 4t, and negative times positive will become negative. 1 of times 16 will be 8 positive 19. So now we can do further simplification. So h of t equals to negative 1 over 2 times t square positive 4t. So now I have to combine negative 8 and positive 19. I'm getting positive 11. Okay, now I got the quadratic function exactly in the form that we have in the question. So now what we have to do is we have to compare this form and the one we got over here, that is h of t equals to a t square positive bt positive c. So comparing this and this, at the place of b we have 4, at the place of c we have 11. So we get b is equal to 4 and c is equal to 11. So our aim is to get the value b positive c. So b positive c equal to 4 positive 11, which is equal to 15. So now I got the value of this expression b positive c, that is 15. We find 15 in option D. So the correct answer choice for this question is option D.